Hey Grease Monkey, are you cramped into a hellhole tangled in a rat's nest of wiring trying to find out where that broken wire goes? In today's video, I'm going to be covering how to read an aircraft wiring diagram. My name is Mark, and you're watching Hangar Hackers. Alright, hey everyone, welcome back. Got another video here all about how to read aircraft wiring diagrams. So we're going to get right to it here and transition over to some slides. I got some screenshots of wiring diagrams and symbols and all that good stuff. So I'm just going to flip over to it. All right, so from madness to mastery, let's get into these wiring diagrams. So what we're going to be covering today, what do you even do with these things? Reading hieroglyphics, so all about symbols, and following the yellow brick road. So ultimately, how you trace wires back, find out where they go, what they do. And before we dive in today, I also wanted to mention that I have a free aircraft mechanics quick start guide. It's really helpful if you're trying to get your A&P, or even if you have military experience and you're looking to switch over to the civilian side, or not even sure where to start. Maybe you're finishing high school and trying to figure out the best path to take. If you're interested in becoming an aircraft mechanic, check out the link in the description below. Download it for free, no problems. Okay, so the first thing we want to talk about here is what you do with these things. So I wanted to mention 3 common uses for wiring diagrams. The first one is troubleshooting. This is probably going to be what you most frequently use wiring diagrams for. You've got a problem. A component stopped working. Somebody brought in an aircraft with a squawk on it, and you're trying to track down what's going on here in today's world of avionics and everything being electrical. This is going to be a really common thing. Another case where you're going to be, if you're installing a new system or upgrading an existing one, maybe with a service bulletin or a supplemental type certificate, STC, pretty common to have an electrical installation with those. So you might be modifying something, taking out the existing wiring, repinning connectors, something along those lines. And the third one, maybe you've got some extra time and you were just wanting to learn some extra components of an aircraft that you work on a lot and just want to understand the electrical system better. All right, so the second part here, wanted to talk about reading hieroglyphics. Some of the most common symbols that you're going to find in wiring diagrams. So maybe this is just a refresher for you if it's been a while since you've looked at electrical components or diagrams or schematics, what have you. And it's just been a while since you went through general side of things with electrical systems. All right, so the first category that I want to talk about was boxes, computers, components, black boxes. And so these would be your avionics or their switches, audio side, radios, what have you, and the connectors that go into those components, and then also the pins inside of the connectors. So those are the common things that you can see on the wiring diagrams. Next up is going to be the actual wiring itself. So there is going to be, hopefully there's going to be labels on the wiring that tells you what system they're part of, what the gauge is, and then the type of shielding that's on them, if any, and then shield drains if there's any of that going on at the end of the termination side of the wiring. All right, and then next we have all of the basic components that you're going to see very frequently. Power, so that's going to be like a source like a battery, or maybe a generator, or even an AC system that's going to be generating power for the aircraft. Your grounds, data wiring, splices where multiple wires might be connected together, diodes, resistors, switches, circuit breakers, and antennas. So I think these are the ones that are most common in aircraft wiring diagrams that you're going to be getting your hands on. And then lastly, I wanted to mention that another thing that you're going to see a lot is references out to other sheets. So you'll see an endpoint of a wire or maybe a connector that goes out to a different system that wasn't able to fit on that sheet. So if you've got a big system and you've got multiple sheets, just wanted to make sure that we understand how to get to the additional sheets where that's referenced out. With symbols here, just going to go through these top to bottom, left to right. So the first one up on the top here is going to be a battery. So a DC system, that's your battery symbol where this voltage source is going to be. Apologize, some of these are a little bit blurry. I was trying to quickly get a bunch of these pictures of the symbols up into my presentation here, but next one down here is circuit breaker. So commonly found in circuit breaker panels for the busing of the electrical system. Next one down is going to be a momentary switch or like a push button switch. Next one down is going to be like another type of switch, two position. So flip up, flip down. That's going to be either on or off, not momentary. Next one down here is relay. So could be normally open or normally closed relay, but you can see up here is the energizing coil, and then down below it is going to be the switch part of the relay. And then up here next in the middle, we've got the symbol for ground. Then down below we have resistors, rheostats. So A here is just a regular resistor, and then you're going to have variable type resistors where maybe there's like a knob or something that adjusts the level of resistance in the circuit. Next one down here is a diode. So diodes only allow current to flow in one direction. So on the cathode side, this is going to allow the current to pass through this direction only. So you can kind of think of it in this arrow pointing to the right here, the current's only allowed to flow from left to right and not right to left. So you can kind of think the line here is blocking current flow from right to left. It's only allowed to flow from left to right in this case in the symbol. The next one down here is just a light, and then down below that we have an antenna. And then on the far right side here, we have the different types of wiring. So this first one is just a single conductor that's shielded. That's what this circle represents here, is shielding around the wiring. And that's going to be to prevent any sort of electromagnetic interference from happening to the wiring. Next one down is going to be two conductors. So also can be referred to as a twisted pair, but the circle again means that the wiring pair is shielded. And then below that, same as the above, but you can see that the shielding is going to be taken to ground. You've got the ground symbol over here, similar as to what's up here in the middle. And then the one on the bottom is just 1, 2, 3, 4, 5 conductors. So depending on the type of wire, like I've even seen an HDMI cable where it's got tons and tons and tons of wires that's all shielded together, and maybe some wires will be shielded individually together. So you might have a pair of wires that are shielded, and then you've got another shield that goes over the entire cable. So those are the different types of wiring here. So hopefully that's a good refresher on electrical symbols. And we'll move on to the next slide here. All right, so next I wanted to take a look at the boxes and what the parts of those are going to be. So I apologize again here for the blurriness, and hopefully this shows up all right for you. But on the left here, this is a multi-purpose interactive display unit. So on the aft electrical panel. So just a description of what the unit is, and then on the far left here, this is going to be is likely a designator for the component itself. So on the location, you might see a label for it, M1970. So yeah, underneath the component here, got a description of what it is, and then where it's located underneath that. So the box around the box shows where it's located, and then inside the box, you can see all of the different parts that are kind of carrying out the activities of the electrical system. So it's just kind of a short description of what is going on inside of the box. Generally, you don't need to really concern yourself with this too much unless you're doing some really, really deep troubleshooting. But you can see here, got lights, and then the power input, and then it looks like next one down here is a common, so that's probably ground here. But you've got data bus here, A and B, so there's usually a high and low side for data bus wiring. So without going through everything here, you can just kind of see that we've got a description of the different operations that the wire do for the box itself. And then outside of the box here, we've got the connectors. So this sort of chamfered, I guess, rectangle, if you want to call it that, is the connector that connects to the component itself. And then you've got a little break symbol here that shows that this was just not able to fit into the section. So depending on kind of how cramped the diagram is, they'll just sort of cut the component or wire or whatever it might be to just so that there's a break and that there are other pins going into the connector here. So yeah, this is the connector, and then you've got the connector label here, which is D3001. And then if you look over here, you can see this is also D3001. Whoops, sorry. So you can see that there's a break here and a break here as well. So these are actually both the same connector. And they're just illustrating that just to squeeze things in, that these pins are going into the same connector, but they just drew them in different sides of the box here. All right, and then the letters on here are going to be the individual pinout on the connector. So I, N, A, B, C, etc. Those are the individual parts of the connector where the wires are actually connecting into the connector itself with a contact, whether it's a female or male pin. It just is telling you where the wire is located within the connector. All right, and then over here on the right, I also wanted to talk about wire labels. So actually, I'm gonna pop over to this example that I had pulled up, just because this is blurry. So I'll try to zoom in here a little bit better. Yeah, I think that's better. Hopefully you can see that. Okay, so generally for wire labels, there's going to be a system that's designated before the wire size. So depending on the system, each manufacturer is going to be different. These might be based on ATA codes, but 058, that might be part of another system that's connecting it into this display unit. And you can see up here, you've got in the series W851. So that's probably going out to a different system. But generally, things that are connected to one connector or component will have like a sequential arrangement of the labels. So you've got 57, 8, 9, 60, 61, 2, so on. So this is going to depend on each manufacturer how they label the wires, but the last wire is generally always going to be the size of the wire, the AWG or American wire gauge. So these are all 24 gauge wires. And then you've got a twisted pair here, like I mentioned before. You can see the two conductors with the shielding going around, and then the shield is drained here. So this is a 20 gauge wire that's taken to ground. Here's your ground symbol. So that's kind of like what the wire labels look like. All right, so pop back over to my slides here. Okay, so last part here, how to actually read the wiring diagram. You can kind of think about it as following a yellow brick road. So there's going to be a beginning and an end, and a lot of different places that the road might touch. So you kind of want to just think about if you're trying to track down one thing that's not working or the other, just start at one end and read all the way through to find out the different parts and pieces that wire or wires are touching along the way. So just kind of think of it as following a roadmap. So first thing you want to think about is what system you're working on, because that's depending on the size of the aircraft that you're working on, could be arranged by ATA chapters. So that's going to help you find out where in the aircraft maintenance manual, AMM, or in the wiring diagram manual that diagram is going to be located. So I would recommend just catching up on your ATA chapters just to make life easier for yourself. Just kind of trying to think of ATA chapters off the top of my head. Like if I don't know, if it was like a radio communication system, you'd be in chapter 23. So that's going to kind of help you quickly locate your wiring diagram. And then I would say use the table of contents or Control F if you're using an electronic manual to help you get there quickly. Find your components, find your wires or pins, and then you're going to trace the wires to find other relevant parts of the system. And some suggestions that I have too here that I've done in the past is make a copy of your wiring diagram if you can print it. Take it out to the aircraft with you, and then make sure I have a note here for yourself to mark it as for reference only, because it's manual could change at some point. You don't want somebody picking up your diagram and them using it as like the legitimate wiring diagram, which could be outdated for some reason. So anyway, yeah, use a highlighter or a pencil or even a crayon if that's your thing to trace kind of where the signal path is going through the entire system. And that helps you add notes or even tabs if that helps you kind of keep track of where you're going through troubleshooting or reading through the system, whatever it might be. Okay, so I've got another example up here, and I think just to kind of walk through more of what we have. Again, you've got the box here on the left-hand side. GTX 330. This example is for a transponder audio panel, and again you can see up here. This was just an example without ATA code, or the wires were not labeled, so they at least have the gauge of the wiring. So just to kind of walk through up here the symbols that we were talking about. So again, the box here, you've got the connector, wiring labels here, and then 5 amp fuse, and then the electrical bus that this is connected to. So this box is being powered from bus 2. And then you can see the cuts here. Bus 2 is probably connected to a lot of other things. So I can see right over here the GMA 347 is connected to bus 2 as well. So both of these components on the same electrical bus. And you can see right off the bat here, the ground symbol is different. So it's just a triangle in this one. And you've got a splice point here with the little dots. And then this is a reference out to a different sheet here. So lighting bus A1. So if you're trying to find the endpoint here of this wire, you would have to switch over to whichever sheet had the lighting bus A1 page on it. So you can see these different ends tell you which sheet to go to or which component to go to find out where these wires are going to end at. Cool. And then on the other side here, looks like one symbol that I didn't have in here were speakers. So you can see a positive and negative end on a speaker right here for looks like audio panel. And then you've got an antenna symbol here, marker antenna. All right, so let's flip over to another example. All right, so here's one from Boeing. So kind of a similar layout, but again, it looks like the symbols and fonts and everything are slightly different. So it just takes some time to get used to whatever aircraft you're working on or manufacturer of aircraft that you're working on to get this kind of get used to how their diagrams work. And you can use the wiring diagram manual or aircraft maintenance manual table of contents to find out where you can get a description of all of the different symbols and what they look like and what they mean depending on each manufacturer. So I would highly recommend doing that before you even jump into looking at a wiring diagram so you can understand how their symbols look. So I'm just going to kind of look here to see anything that was kind of different from the last one we looked at. I think the first thing that I see here are these splice points or terminal blocks. It looks like this is a terminal block, so TB. So this is going to be just kind of a junction point. So there might be many different systems that are connecting to this to lots of different computers or boxes. So got a CDU here that's connecting to this display. So it looks like this is data. So probably the A side data bus is connected here to these two components, and this goes out to chapter 23. So there's likely another communications component that's talking on the same bus as these components. So so that's one thing that is pretty common in wiring diagrams. See here. Another thing that you're going to see too are disconnects. So maybe could be called like a bulkhead disconnect. So you can see down here there isn't a component that connects to this connector, but it's just a female and male connector that are mounted on like a bulkhead. And that's just to pass through maybe like a firewall or a pressurized section of the aircraft, but it's still going to have a connector identifier label to just to make sure that you know where it's located, and so that you can track it down on the wiring diagram. And you'll see a J and a P side. That just denotes the different side of the connector. So P is plug, and now I'm forgetting what J stands for. I think J is junction. Maybe it'll come to me. I'm blanking on what the J stands for. But it's just denoting that there's two sides to the connector, a male and a female. All right, let's see what else is going on in here. Ground symbols, again, those are a little bit different. The shielding symbol, you can see there's, to show that this wire is shielded, it's a figure 8 instead of a circle going around the whole wire. So you can see there are just these subtle differences in the wiring systems, but kind of accomplishes the same thing. All right, this next one I have is from Falcon, 900EX. And I've found that Falcon is they use like a really small font or typeface, whatever you want to call it. And probably the most unique of all of the other wiring diagrams that I've seen. But in this one, this is for service bulletin. And you can see that there are some notes down here where wires are rerouted, removed, or added. And you can just refer to the colors up here. So if you're doing a mod, you might have had to reroute a wire from some component or a component that was maybe added in for the service bulletin. And then for the green, you've got a new wire that was added, and it puts the wire label here. And you can see the wire labels here, even though if they're kind of blurry, they're still very manufacturer specific, and this one is quite lengthy too. But you can see at the end the /20 indicates that it's a 20 gauge wire. Over here, same thing, wire number 16 of the series, but it's a 20 gauge. Number 5 of the series, 20 gauge. And then some of the components down here. Looks like this is a relay, so you can see the coil in here, and it looks quite different from the relay example that I showed before. But you can see the switch inside of the relay, and then this relay has an identifier. You got some splice points here. These little dots indicate splice points, and if there is no dot where two wires cross, that just means that they just cross over each other in the diagram, and they're not connected in any way. So like this section here, these wires are not spliced together compared to the one just to the right of it where they are spliced together. And you can see a little circle here shows that this is a shielded wiring. And then notes over to where this wire is going to go. 408JE-12 is just showing that that's the component that this is connecting to, but they just leave out any details of it. And then over here, there's a reference out to a different wiring diagram. It looks like chapter 4-61, and it gives a little description of where that's going. 28 volt bus, and the component identifier 52TB, which is probably a terminal block. And then down here, I've got circuit breaker and the bus that this is connected to. All right, and then again in here they show the actual details of what the component does. So in here, it looks like there's some switching going on inside the box, and compared to the other diagram that we had, the Boeing one, it doesn't show you necessarily what components are inside of the box, but they just give a description. So instead of, I don't know, saying that there's a ground here with a ground symbol, it just says chassis ground. But in here, they're showing what the internals of the box are doing. So it just kind of depends. Right, and then I see a diode in here. So this diode symbol, it looks like this is actually like a pinned kind of diode. So each of the wires would pin into a little connector for the diode. So it's like you can remove the wires. It's not soldered together or anything like that. But you can see that's spliced into this circuit here. I think that's kind of it for this one. And well, one more thing here. I just saw this here, 21 FT. So I do know that this FT is a feed through. So there could be some cases where this little symbol here, you don't see any numbers within the kind of like the rectangle that's going around this. That indicates that this is just a feed through. So it's a bung that the wires are passing through, like a sealed bung. And FT stands for feed through. So feed through number 21. So there should be a label on the bulkhead where this feed through is located to show you the location of the wiring. So that's another thing that you can watch out for. If there's no letters or numbers on what appears to be sort of a connector, but yeah, just so that doesn't get confused. All right, so wrapping up here, when in doubt, check your aircraft maintenance manual or wiring diagram manual for explanations of specific symbols. Each manufacturer is going to be different, so just be aware of that. Just takes a little practice to become familiar with what the symbols look like, and yeah, just check for that front matter. To see a description of the symbols and what they mean, and wire labels and all of that good stuff. Second point here, if you could think of simple ways to make reading the diagrams easier, that's fantastic. So print a copy, use highlighters or pencils, and make notes, whatever you need to do to make life easier out there while you're troubleshooting or working on an electrical system. And then my last point here is don't be afraid to ask for help if there's somebody who's a specialist. Maybe if you're an airframe person, maybe there's an avionics person who is experienced with wiring diagrams. They can help you out if they're not too busy. Or if there's a tech rep that you have on site, they can help explain, especially if it's like a manufacturer-specific component or like a new installation. A tech rep can help you out, or just other experienced technicians that are on your team. Just don't be afraid to ask for help. There's going to be someone that will always have more experience than you and can help you out, or you might even be the person that's helping someone else. So keep that in mind too, just to kind of share the knowledge with other technicians out there. All right, so last thing to touch on here, if you're struggling with anything, or if you've got some goals in mind, maybe for your career, or maybe different aircraft that you want to work on, or like a different job role that you're looking to do, throw it in the comments. Especially if you're struggling with something, I'd love to see ideas for new videos that people need help with. Hopefully there's something that I can provide to help everyone out. We'd love to see that in the comments. And then if you jumped in After the beginning, just again wanted to mention that I have a free A&P Quick Start guide that you can download. The link is down below in the description, markhjoy.com/quickstart. If you're looking to get your A&P and understand the process, or if you're transitioning from military to civilian, or if you're just kind of looking at the A&P process and trying to understand if that's something that you want to do, hop over and download that. Really helpful. Has lots of great links out to other content from FAA and other great resources in there. So hope you like this video. Again, put something in the comments. Let me know what you want to see, and I'll try my best to help out. Thanks for watching, and we'll see you in the next one.